Hello, hello, and welcome to the Train Buddy Shop. Once again, we have an exciting change today. We're going to do an N-scale locomotive, and this is a lifelike BL2, and I've actually got two of these that the gentleman wanted me to put DCC in and possibly sound. So I saw this as an opportunity to bring up a couple points about putting DCC into a locomotive and also sound. One thing to note here is that I'm going to do whatever I can do to do the things that he wants to do, and we'll advise him accordingly. This is a BL2. The BL2 part is not the issue. The issue is this is an older style lifelike engine, and the lifelike engines had it's not the first one I've seen, and not the first one that I've put DCC in either. These engines had a lot of fill metal, so you can see the fill metal pieces here, and I've taken them off. It's kind of it probably has a lot of lead content in them. They're not soft to the touch, so they're probably not 100% lead, but they look like, and they drill and saw like they have lead in them. The blackening there, this is blackening here for the light. On this side there's no light, but I don't expect there would have been. It's blackening so that it blackens out the reflection coming through the window when this is set in place. All right, so the question starts out with, and should always start out with, whenever you're going to do this, is the motor capable of handling this? In other words, does the motor draw more than the rating for the decoder? Many decoders today will take at least an amp, so we're looking to see what the value is here. And one of the ways to do that is with the bench and using a bench power supply. So I've used the bench power supply. I'm not going to show that condition, but this one actually does pretty well, even though it's what we call an open frame. It gets about 0.3 to 0.4, which is 400 to 300 to 400 milliamps at the top end, even at 12 volts. This one was in fairly poor condition in terms of lubrication. I've had to lubricate everything to get it to work well. I'm going to probably tear out the gears on both sides and clean them up and then re-lubricate them. It worked fairly decently from that. We can look at the gearing on the bottom. You have open gears to the rails and to the ties, and so for that reason, and that reason alone, you should make sure that you always vacuum your N-scale layout to make sure that there's no debris. Just a little piece. I've said this before. Just a little piece of debris, a piece of talus, or a piece of ballast, or a piece of foam, which is used oftentimes for scenic material, can easily get inside of these gears and then render this thing useless until you take it apart and clean it. All right, so another reason to make sure that your decoder will handle the motor, if the motor in fact is stalled, and that can easily be one of the reasons why it's stalled, just because we get something in those gears. All right, so now we take a look at, all right, mechanically everything's well, the current rating is good for the motor. Where are we going to put the decoder? All right, so I'm going to get tighter in on this situation so we can look at it. I'm going to kind of set it aside here. We're going to look at the side view of it. Again, this is the frame, right? Here is the top. the shell, right? Here's the frame with the motor. Here are the two weights, right? So we're going to put the two weights in just so you can get some good idea of what's going on. Get that other weight on there. Right, and we're taking a look at it. Notice that because of the way this is structured here, that pretty much fills that cavity. There's not a lot to the cavity. There's a couple of light pipes that start here because the light bulb, right, goes right in the center and then goes out both sides. All right. So one of the things that we want to do probably is cut those light pipes back and put LEDs, put one for the front and one for the back. Right? And then we'll take this big light bulb out. All right, now, where are we going to put the decoder? All right, so we've got a lot of different options here. Let's start off with the one option, which is sound. Let's see where we are with sound. Well, we can use Tsunami, and this just as a reference. These are some of the smallest sound decoders that you can buy. There are other sound decoders that are made specifically for N-scale, but they are in a board, and there is no board for this just because of the age of this particular locomotive. If I look at just the width of this, right, you can see that it probably will work here. When I look at it from the distance here, I could probably put it in there. I might be able to put it in there, but what I'm going to have to do is I'd have to take the weight out. All right, now looking at the edge of it, right, looking at the edge, right, I might be able to get it there, but when I take the top off and I start looking at when I take the weight out and when I start looking at where I'm going to put it, right, I might be able to squeeze it in there, maybe, all right, might be able to squeeze it in there. We're going to have to put some ledge or something to keep it from, first of all, to keep the screw from popping out. There's no top on this, right? So we'd have to do something there. We'd have to make sure that we don't get into the rotating parts here. And then we have to put a speaker in. Well, this is the smallest speaker on the market today. This is some people call them a cell phone speaker, but mini cube speaker. Now the speaker itself is a small slab on the top, and probably we could put that in there somewhere. All right, we'll put that in there somewhere. The issue we've got is the same here. I would have to carve out the metal, right? Have to carve the metal out of the top, and then there's no cavity for it. If I was to look at the cavity itself and the height of that cavity, there's just, I'm sorry, just no place to put it. Okay. Now we could do a little experiment maybe, and we could take one of these and take it out of the cavity. I've shaved the cavities down before and tried to make that work. I don't know. We're talking a good amount of money here. We're probably talking this decoder MSRP is $130, right? A good chunk of change, even at Train Buddy prices at $103, plus another $10. For the speaker, we could go with this, which is a smaller sound system, kinda, but now this is the European model. It's too wide, right? Just won't fit in there. Even if we could use the Soundtrack's adapter, right, 21 pin, now all of a sudden this is way too big. We still have to find space for the speaker. So unfortunately, unless I got really bored and wanted to spend a lot of money on this, and a lot of time trying to make it work, I'm gonna say no. Let's do. I might be able to get somebody else to do it, but I'm going to have to beg off on that. Let's look at putting just a regular decoder in there. Now we might have a fighting chance. Here's a decoder, again, from Digitrax, a DZ126. And the size of the decoder now looks pretty good. This is a Z-type decoder, right? Again, it's good for 1 amp, which is plenty well good enough for this. 1 amp and 1.5 amp peak, right? And it's a 0.5 amp typical, right, for the functions. So that's plenty good enough for the LEDs. It looks like it would fit in there. Now we may have to shave some stuff in order to make it work. Again, putting the weights back on it and taking a look at it. It's a little bit too thick. So looking at this room between here and the top, it's a little bit too thick with its other with the shrink tube on the top of it, or to fit in there. Okay, we've got another alternative. Again, a Digitrax decoder. This one is a DZ126IN, and it's a 6-pin. And if you'll notice, the size of that is pretty small. That's a pretty small decoder. Will that fit on top of that? Yeah, probably. And this is the decoder, by the way, that I used for that Sperry rail system, really small N-series engine that I did. And while this one would probably work, it's probably nice and thin and probably would fit just right there and allow us to do all the wires and everything, there might be another alternative. Now this is like $23, typically $28 retail. My preference is this guy, a Z2. Now this is $41, okay? But the decoder is that big. In other words, it is tiny. Tiny, tiny, tiny. And while it's probably about the same size as the IN, DZIN, and again, this is a Z2 made for a Z-scale locomotive, it's got wires on it. And the wires then make it a whole lot easier to fold and to put inside of this. And this is my actual preference. Now, would that be the customer's preference? I don't know. But he's asking me to do this. Again, I would, for the cheap alternative, I would do the Digitrax one. I might be able to make that work, maybe. So I would take some measurements there, and I'm going to measure that, measure the depth here, right? Measure the depth down here on the side, and we'll see if we've got enough headroom above this to do the cheaper alternative. Because again, this is even Train Buddy price, $41, right? It's 48, almost a $50 decoder. So you don't want to use that one if you can get away with a $20 decoder. All right. So let's see what we can do there and see if we can make that happen. All right, I'm going to do some measurements. I'll be right back. All righty, so without being biased here, another alternative is the NCE decoder, which is the 524-119. 119 is their, well, I guess the 524 is their number 2. In any case, from NCE, this is an SR, not the, well, the N12 NEM is similar to one of the other ones, except this is actually an N12 SR. This is their smallest decoder, and again, it's pretty much the same size as the rest of them. Notice that this one will give us the amount of room that we're looking for. We're looking for a half an inch. We're looking for, or half an inch. We're looking for 0.05, 50 thousandths. This is 132 thousandths, okay? That's 132 thousandths. The DZ 126N is 36 thousandths by 42 thousandths by 0.13 thousandths, or 1.3, so 130. It's about the same height, right? Again, we're restricted here pretty much by the chip. If we go back to the Digitrax, the DZ126, which is again our other alternative. This one comes in at around 150. Well, that says 116. That's pretty good. 120, 130. So that one's actually thinner than this one. Not quite sure why. Well, no, about the same size. All right. So we could use the NCE decoder. Unfortunately, I don't have one. Right. I mean, it shows one there, but that one's burnt out. So that's another one that we could use here. But again, looking at the price, not much difference there. $41.95 retail. Train Buddy $35. Okay. So we could have used that one. We could use the inexpensive one, which I think we're gonna opt for that one, or the 125 IN. We're either going to use the 125 IN or we're going to use the DZ 126 with the tails on it. This one's 23. This one's 18. I'd rather use the one with the tails. Let's see if we can make that one fit. If I have to abort, I will. But I'm thinking this one just might make it. I may have to play some games here, and we'll talk about that as we go along. Alrighty then. So with some finagling back and forth and some fitting and trying to see how to make it work, I just put the wires up a little bit, and I'm looking really for, is the top going to fit down on it? So with this double-sided sticky tape right here to the top of the motor, and it flat like that, it just barely makes it. Now I may want to file some of the extra shrink wrap off the top of that. The key was the light pipes, and so we were going to take the light pipes out anyhow, but that thickness right there was enough to keep it from actually coming down on top and snapping in place. So with that being said, and this was mainly the reason for this video, we're going to stop it right here, and I'm going to just go ahead and put it in. I don't see there's any difficulty once you've decided what decoder to put in there and how it's going to fit. It's just to do the numbers, clip the leads, put the wires in the right place. And we'll even have room to keep this weight in, and probably this weight. I don't even think that we're going to have to shave anything off the weights, and that will make this a better experience for this customer too. All right, that's the end of this video. All righty then, the end of this video. The headlights, the head and tail lights, I've put LEDs in, and I've used where is it? Where did I get it? It's back over here. I used some of this Tester's canopy glue, or clear part cement they call it, to put in the glass for the headlight and the rear light. You can see I used a little bit of putty. I also used this on the inside to hold the LEDs in. So the challenge is always to get these wires connected to these wires and make them stay. I can show you that if you want. All right, I'll show you how to do that. But the important part here is we got to put resistors on, right? And we're going to shove those down in a hole. I've already completed one of these, right? So it is done. This one is done, right? And I'm ready to do the second one. And that's what we're looking at here. So without further ado, I'll go ahead and do that. So the first thing we want to do is decide where we're going to put the resistors. And we need 2 resistors, and I use these little 1/8 watt. Use the 1/8 watt resistors, and we're going to cut them fairly short. Cut the ends off them so that we're not putting a lot of room. They're not taking up a lot of room in the shell. We're going to try to put them like right down in here and up on this side, back up in here. All right, so this is the front, this is the back, this is white. All right, so white goes to the front, right? Yellow goes to the back. And again, we're not going to do much here. By the way, this decoder in here is a little bit different. This is what they call the 126T decoder, the DZ126T. Okay, a little bit more expensive. That's what I had in stock. I probably should have used them on both of them. I had 2 126Ts, but it is what it is. So I'm going to go ahead and cut this to length here. And we're going to add the resistor on the end of that one. This one, going to cut it about right there and add that on. Now the blue one, I could go, since it's common, I could go back and forth, but I've got all this extra wire here. I'm not going to need it. I'm going to cut the blue one back fairly short. I'm going to cut it back to about right there. And you'll see in a minute, all the red is going to tie in, the positive leads for the LEDs is going to tie into that. All right, so let's look at the LED leads now before we start doing our soldering. Again, the reds are common. This one coming off the top, you want to kind of push them towards dress them towards the top of the shell. So I'm going to use my tiny hands here. Right, get a hold of them and kind of push them in there. You can also use the back of any implement you've got that will fit in there. My fingers are getting too fat to do some of this stuff. All right, put that in there. Let me see if I can hold it and then push it. Use the sticky to hold it in there. The one in the front looks pretty good. All right, and we're going to manage these. Now the one in the front is going to come through about right there, and we got plenty of room to bring the shell up and over. Make sure we can do that. And again, this one has to go all the way out here in order to clear the coupler, right? So we're going to use that as our guide, and we're going to cut that about right there. Okay, the other one now, the one that's coming from the back, we're going to loop it a little bit. We've already got it kind of looped. I'm going to loop it just a little bit. Now we don't want to have so much that it's going to get down into the motor. So let's try to be cautious here and cut it right there is where we're going to. What's wrong with my cutters? There we go. Cut it right there. Okay. And then on the green side from the front, just has to come up and connect to this resistor. Again, try to loop it around like this. We're going to leave that one about right there, and the other one is going to come up and loop around. And again, we don't want to have too much wire to it. Right, bring it up here, and at the end of that resistor will probably be somewhere around there. Now these are not too critical because these are very, very tiny and they're going to ride up inside the shell. Okay.